the aim of the EDQC is to create a place for the dairy and alternative markets, to create a community with conferences and with also a group. Most of you have joined the LinkedIn group, the EDQC group, which is a wonderful place for our community to share, comment, question about trends, challenges, or whatever, and this along the year. We have chosen topics of interest that are tackled by experts, and in advance, thank you for the speakers of this 2021 edition.
Anne Bigalke is the VP of Sales and Marketing at QualiTru Sampling Systems. She works with a dedicated team and set of global partners to help improve food quality by filling the missing gap of accurate and in-process sample data. With continuous university research and on-site trainings, dairy plants and farms can improve their product quality and operations with aseptic and representative sample data. Anne is going to address us on the issue of is technology blinding us. With that, with no further ado, Anne, I want to put you on the spot here, and we're really looking forward towards your presentation. Thank you.
My name is Anne Bigalke, and I'm the Vice President of Sales and Marketing at QualiTru Sampling Systems. And today what I want to talk about is how technology advancements may be blinding us from the simple actions in process monitoring. I will then build a case for accurate in-process sampling. And I'll just note that this conversation of bridging the gap between testing and sampling started about 2 years ago when I met with Jack back at the 2019 European Dairy Quality Conference. And that we identified this gap between sampling and testing, and it evolved to an engaging conversation. And here we are today to talk about how we can improve our quality with sampling and testing together. I will question the technology advancements and how that may be blinding us from the simple actions of process monitoring, then building a case for in-process sampling. In the last 10 years, we've seen a significant advancement in gathering more data with blockchain or big data, broader data with environmental testing, and faster data with the sophistication of rapid test. However, we still face contamination challenges. So today I want to talk about in-process monitoring and specifically about sampling and some ways that we can mitigate that contamination from contaminating our lines. I will define in-process monitoring as the evaluation of closed process, i.e. what's inside the line or the closed environment. I'm not saying that the environment is not important, but there is a missing gap in the resources and the regulations on how to monitor what's going through your line. So the goal for the presentation today, and really the goal for the dairy industry in general, is that we want to prevent contamination, improve food safety, and operational efficiency. Today I'll talk about why to monitor your process, to cover some sampling considerations and best practices, and then finish with some operational efficiencies and cost savings. So, as all of you know, dairy is a challenging product to monitor. It's an ideal growth medium for bacteria. It's rich in nutrients, has an ideal pH, there's plenty of water, oxygen, and there's an absence of inhibitors, making it a big challenge for the dairy industry to manage and control. Here's a picture of stainless steel and Pseudomonas growing on that polished stainless steel, developing a biofilm. So biofilms are another big challenge for the dairy industry in that they can inhibit spoilage in your products. So biofilms occur within the pipe or within the processing environment, making in-process monitoring an important program for any good quality control program. Spores are resistant to chemicals, heats, and sanitizers. Pasteurizers may heat shock spores into growth, and steam may not kill all spore-forming bacteria. Therefore, biofilms are an ongoing challenge and something that we need to be monitoring for on an ongoing process. So what is the impact? Process monitoring can help identify where in the process contamination is introduced. Then it can help prevent future risks with ongoing quality assurance programs. If you have bacterial contamination in your process, you can source the location and defect. For example, if you have gram-negative rods, that can be an indication of post-pasteurization contamination. So contamination introduced after the pasteurizer, while gram-positive cocci in rods can indicate thermoduric contamination or pre-pasteurization contamination. Do you want to mitigate or manage your contamination? Contamination is managed with sanitary design, effective cleaning and sanitizing, proper hygiene, training, and SOPs. However, you may have all of these in place and you can still experience microbial contamination, and it's often experienced in low levels. So what you want to make sure that you do is have a good understanding of your manufacturing process, track patterns of variability over time, and look at the historical stability records as well. And most importantly is you want to have a willingness to use the data to drive improvements. Identifying low levels of contamination starts by evaluating your entire process. If you have contamination, effective process monitoring can identify the source of contamination. If you don't have significant or known contamination, effective process monitoring can verify process controls. This includes hygiene, training, and proper design. Ensuring good final product starts at the beginning with receiving and material handling, and then it covers all your critical control points along the process. So typically what we recommend is to start with your critical control points at the very end, that may be up to the filler after the pasteurizer, and then looking at what's coming into your facility at the very front in the receiving and handling, whether that's unloading the trucks or on your raw silos, and then working your way in the middle, depending on whether you have aging equipment or specialized equipment. You want to identify unique spots to be able to verify your controls. We're going to jump into our first poll, and the question that I am posing to the group today: how many in-process microbiological samples and tests do you take on a daily basis? So first off, do you take no samples? You're only looking at your final product and then putting together a plan and a corrective action plan based off of that final product. Are you taking 1 to 10 samples? You know, maybe that's near the end. 10 to 20, starting, you know, kind of basic throughout your process. 20 to 30, pretty robust, and then 30 or plus. You have a very good understanding of where your product specifications are meeting intended results, or you're putting a really preventative control action into place. You know, my role is to really focus on having good samples, and we see really across the board, depending on the history of the facility, if they've had challenges in the past with certain equipment or they have a specialized product, typically we see more sampling being done. Whereas some facilities that are a bit smaller, they don't need so many samples because there's less equipment to track. It can also vary depending on customer requirements as well. Great, so here's the result that we have. About 9% take no samples. Looks like the majority take 1 to 10 samples. I'd be curious to know where those samples would be taken. Close second is 10 to 20, following that 20 to 30, and then 30 plus. So there's a pretty nice spread between how many samples for microbiology are taken. I'm assuming that could go up if we're looking at chemistry as well, but this is nice to see that samples are actually being taken on a regular basis. Okay, we'll jump back in. So talking about standardizing raw milk sampling, so that's really getting controls on the front end to improve your final product quality. Standardizing raw milk sampling and testing practices allows companies to have greater sensory and quality consistencies with the final product by gaining control at the front end. A Canadian company had inconsistent SPC counts that varied depending on the sample collector, the time of day, and equipment. By standardizing the sampling process and the equipment on the tanker truck, the central lab was able to gain better control on the raw milk quality coming into the site. They have a representative sample of the component levels coming in, as well as the microbiological levels. The data today allows the central lab to get better control of what's going into each facility to make greater consistency in the different sites, to have a more consistent final product across the country. So why does in-sampling process matter? First off, meets regulatory and quality requirements. That could be HACCP, SQF, BRC, but more importantly, it detects product quality or process implications before final product testing. So you don't want to wait for your final product to come back with variable quality or microbiological levels. You may be making the wrong or improper corrective action. So what you want to do is to take ongoing data to prevent variables and questions on the back end. You can identify operational efficiencies and cost savings when this is also done correctly and you're asking the right questions. So talking more about cost savings, there's a Dutch plant that was testing pasteurized silos to meet their HACCP requirements. In doing so, they would flush the sample valve with product for 15 seconds prior to collecting their sample. The quality team calculated the cost of running each valve for 15 seconds over a year, and they discovered 50,000 euros in savings. They not only identified cost savings in their sampling and testing plan by not wasting product, but they implemented an aseptic sampling system to do their test to understand the true product quality. Going back to what to measure, so when you're building a sampling plan similar to the Dutch plant, you want to consider what requirements you have for your process and your product. By separating the two, you may have different objectives, and it's important to understand and highlight what those may be. Is your process hygiene meeting specifications? So more specifically, have you properly validated and verified that your equipment meets specifications? So that could be looking at specialized equipment. That could be your pasteurizer, or you have certain filters in place. You want to monitor your sanitation and hygiene. You could be detecting biofilms. So maybe with aging equipment, or you want to confirm that your CIP is working correctly. But then you can also optimize process times by gathering data in process and comparing that over time, and perhaps extending time slowly and looking at that data trended over time. You can allow yourself to either expand or to reduce your times. With product, you want to question, is your product meeting the microbial or chemical specifications? This is especially important if you have high value or high risk products. You want to look at your process, starting with the critical control points, and put a good plan together to make sure that you're meeting your controls at those locations. You can compare component levels at the very beginning of the process to the very end as well. You can even take the time to look for psychotropic contamination in high risk areas and make sure that you have the right controls in place. Next, I want to talk about an Australian whey plant that was struggling to monitor their filters for potential tears. They faced strict quality requirements for exporting product to China. To monitor their filtration skid, they had to meet their customer requirements and their process specifications. They put an in-process monitoring plan to test and sample at the beginning, middle, and end. And they would compare data between sites and over time to make sure that the proper solids are being removed at the right places, and that was consistent over time. By comparing locations, the quality team could detect variabilities in their process over time while maintaining confidence for their audits. They were able to extend the shelf life of their filters as well, just because they were trending their data over time, and they found that they were replacing certain filters faster than necessary. So by having good in-process data, they were allowing themselves to really get the full use of their equipment in place, and having confidence that they were going a little bit past what they had originally put in their benchmarks for when they had auditors coming through. So your microbial analysis is only as accurate as your sample. Other words, your test result is only as accurate as your sample. So if you have a good testing process but an inaccurate sample, you may be making the wrong decisions based off of that sample, and vice versa. If you have a good sample but you don't have clear and consistent methods in your laboratory, you may also be making the wrong decision based off of that data. So without the combination of the two, you risk having continued microbial contamination. You want to ask, is your sampling process introducing contamination with poor training or non-hygienic equipment? You may have misdirected control efforts. Did you sample the next batch or dump product unnecessarily? You may have wasted laboratory efforts. So did the lab communicate back to the sample collector to fix future problems? Without a good sampling and testing plan, You may not meet regulatory compliance. And last but not least, you may just have frustrated personnel. There's a lot of questions that can go around if you don't have good sample data and good testing efforts that align together. So what is good sampling? You want to start off by questioning, what's the difference and what is necessary between aseptic and sanitary? This goes back to the question of, is your sampling process introducing contamination in your process or in the sample itself? So aseptic is free from contamination caused by harmful bacteria, viruses, or other microorganisms. So essentially, the process of collecting a sample is free from introducing unwanted bacteria, while sanitary is relating to the conditions that affect hygiene, health, and hygienic and clean. So what you want to do is to look at what type of testing you're taking, whether that's chemical or microbiological, and question, how clean of a sample are you looking to have? Does it need to be free from contamination, or is it okay to have a sanitary process in place instead? Does that need to be consistent across your facility as well? So those are good starting questions as you look at what level of hygiene you need to have as you're collecting your sample. Identifying contamination. A Canadian food plant had spotty SPC counts in their final product. This problem made it difficult for the quality team to know if contamination was introduced in process or if it came from receiving. To identify the source, the team came up with an aseptic sampling point plan throughout their process to obtain a contamination-free sample in critical areas. They found bacteria from a suspected biofilm that was taken off a holding tank. Since then, they kept the sample points and take ongoing tests to prevent future spotty problems. I'll just add in that spotty problems may be consistent problems. They're just identified infrequently because of low volumes. So if you're having variable SPC counts, what you want to question is not just, is it coming in somewhere in my process, but is it something that is really contaminating more of my product, or is it just coming in frequently in our final product testing? As a part of a good in-process sampling plan, training is important to monitor your process and mitigate contamination. You want your team to think along the same lines and to gather the right data to make better decisions. That starts with clear training and SOPs that highlight the end goal, but also build greater consistency between the data being gathered on the floor and how it's being processed in the lab. You want to have the proper hygienic tools, so that goes back to needing, aseptic procedures or not. If you have aseptic technique, you need to communicate what does that mean to the proper sample collectors and make sure that you have the right equipment in place to follow that through. You need to label samples correctly so that you have consistency between what's on the floor and what's being brought to the lab. Sample storage is also important. So if you're doing microbiological testing, you want to keep your sample cold to make it representative to what was pulled from the line or the tank. Making your plan consistent and replicable is important to make sure that you have consistency over time, so you're comparing data as apples to apples. And track and trace is also important. As you think about the end goal in mind, you want to decide whether you need a grab sample, a small volume sample, or a representative sample, a larger sample, or looking at the entire run. Grab samples is a small volume or a snapshot of the process, while representative samples are a larger volume and factors the entire population or the entire runtime. Often we see QA teams using grab samples for micro testing off a tank or a silo, while they'll use a representative sample for inline micro or chemical sampling. So it really depends on if you're looking at the entire process or just a piece of the process, and that will really determine what type of sample that you need to have in place. Representative sampling. My last case for today is another Dutch cheese and whey plant that experienced variable microbiological data in a line connecting the two sites. This was a challenge because payment was based off of that data, and the data was variable depending on the day and depending on other factors. The two plants worked together to put an aseptic and representative sampling plan together to accurately obtain a small sample of the entire line. Using aseptic sampling equipment and a peristaltic pump, they could track the micro and chemical levels exiting the cheese facility and entering the whey facility. The aseptic and representative data allows both sites to agree on the payment and to better track the quality on a daily basis. So building a long-term strategy. A good process monitoring program starts at the end in mind. What do you need to know about your process? Starting from the microbial risks, operational efficiencies, and looking at cost savings. Training may influence the results and decisions. That's why it's important to make sure that your sampling and testing goals are transparent and that everyone who is working with the samples and tests have the same mindset. It's also important to note that one data point has a short-term reflection and must be compared with both the date and the location. So for example, if you take a sample off the pasteurizer, a grab sample, that's a reflection of the product moving through the pasteurizer in that moment. It doesn't reflect what was going through yesterday or what will go through tomorrow or the entire run. So you want to question how robust data do you need to collect of your process? And last, the data must be used to make improvements. If not, you may be missing an opportunity or you have the risk of experiencing spotty problems. In summary, going back to our goal at the start, we want to prevent contamination, improve food safety and operational efficiency. To achieve that goal, process monitoring and in-process sampling is necessary for any good quality control program. Effective process monitoring requires aseptic and representative sampling to have accurate test results. It can also improve customer and consumer experience with greater confidence in your shelf life and having the proper risk management program in place. And you can hopefully also identify some cost savings or operational efficiencies as well. To help and make those improvements with your process monitoring plan, I hope you take away these 4 things today. To first, start with the end goal in mind. What are you trying to accomplish with your testing plan? You want to monitor your product and your process by separating your intended goals for both the process and the product as well. You want to question whether you need to have an aseptic, free from contamination, or a non-aseptic sanitary sample. And last, questioning whether you need to have a representative or a grab sample in place. You know, why don't we jump into the last goal now? And the question I want to end today is that, you know, what are your major concerns with in-process monitoring? Is it first going back to your quality requirements or regulatory requirements of meaning HACCP, SQF, or other frameworks? Is it to meet food safety goals and really controlling pathogens or potentially spore-forming bacteria as well? Do you want to control spoilage and improve your shelf life? Do you need to meet your customer acceptance requirements, or is there something that's not listed on here? You know, I think typically we see that it starts out as being a quality requirement with HACCP most frequently. However, I think once you have a good process monitoring plan in place, I think the goals expand over time. So, you know, often that goes into improving your shelf life, and then of course controlling pathogens as well, but those needs may change over time. Great, so it looks like the greatest factor here is food safety and controlling pathogens, with a close second of controlling spoilage and improving shelf life. Next, the quality requirements and frameworks, meeting customer acceptance, and then a few others that are not listed as well.
And thank you for your presentation. I think your presentation stimulated where we're going with Jack afterwards. I think very interesting is that whatever you've discussed in terms of accuracy, in terms of in-process sampling, is this, the necessity to work towards a proactive approach rather than being reactive. So having what you've said in place is really the core of the business, and understanding your specifications and know where you're going. Thank you very much for your presentation. It's I really appreciate it. Thank you so much. And if there's a question relating to aseptic versus sanitary versus sterile sampling, how do you, when you apply the difference between your aseptic versus sterile sampling?
It goes down to really your goals and your testing plan. So if you need to have complete contamination free in your sample itself, you want to look aseptic. Sterile is really the process that you're using to clean your equipment. That could be used for chemical testing, but aseptic is one level above that. So typically we suggest for microbiological tests, go for aseptic chemical. You can choose aseptic or sterile.
We also received, thank you, and another interesting question, how many samples are ideal for the in-process sampling? This question came from John Dipakor.
Sure. You know, it really depends on the facility and what your end goal is, like Jack said as well. We typically suggest starting, looking at your raw milk, taking a sample on each silo to understand your microbiological levels. You also want to have a good understanding of what's coming in on the tanker trucks as well. You want to have select critical control points along your process, and then if you have any holding tanks at the end or pasteurized tanks, you want to sample there as well. If you have water as an ingredient, that's another place you'd want to look at. And CIP verification. You could take a sample in process while you're running your CIPs to check dilution and concentrations. And then following CIP as well, you can check your microbiological loads as well.
Good, thank you. And there's some questions, comments from Chris Edwards. I think I just want to go to one that deals with CIP cleanliness, perhaps a reflection on that, and a reinfection or post-contamination in that respect. And then the effect of environmental sampling and the effectiveness of that. Chris also mentioned the issue of sampling effectiveness. I think, Chris, that Jack really dealt with that matter. So I want to leave the one issue with you, and if you can just respond in terms of environmental sampling and the importance of that on your side. It's not in process, but I think it's part and parcel of contamination of your processes.
I would say a good quality control program looks at both in process, so what's going on in your lines, and what's going on in the environment. So you want to layer the two together to have a really robust understanding of what's moving through your process. You want to factor in the time of day, as well as the sample collectors in that as well. But the two should be working hand in hand to make sure that you have a good understanding of what's entering your process from the environment and what's moving through with your in process, and then again looking at your final product would be that final step as well. Jack,
fantastic.
Onto that? I think you have some really good experiences with both in process and environmental sampling and testing.
Yeah, they're both important, and they complement each other. I think it's really important to differentiate, I think, for in process versus what you do around the process. And for me, they both add certain values. Like we often talk in environmental monitoring about food contact surface monitoring, and for me that's actually in process monitoring. It's not environmental monitoring, so there's the overlap. Again, whatever monitoring you do, ask the question, what is the result going to tell us? What will a positive or negative result mean? Because sometimes we're just curious without realizing that a surprise result may affect our product.
Good. That's the end of today's session. Thank you so much for everybody participating, to the organizers, and most of all to our presenters. Thank you so much. We're already looking forward to tomorrow. Have a nice day.
Yeah, thank you.
Thank you. Bye.
Bye-bye.